instructor and a researcher at securinghardware.com. Please welcome Mr. Joe Fitzpatrick.
So, high speed in the slow lane. I've got 20 seconds per slide, and I've got to be the one who moves the slides forward because I don't trust anyone else to actually give me the full 20 seconds for any slides. So let's get started. This was originally going to be like an hour-long talk compressed into 20 minutes for SAS, and now we've got it in 4.5 minutes. We're going to talk about PCI Express and DMA attacks on cheaper and low-cost hardware. So if we talk about hardware hacking, we rewind a few years back, or actually till current. And what do we do? So this year, we've got a CVE for a root shell on a UART console. This is on a Xiaomi speaker, right? So we're still dealing with the easy hardware hacks, the leaving the keys in the front door with the door open and getting worried when people like burgle you. We've also got firmware, pretty easy to grab off of lots of low-end devices. We've got some probe clips connected to this flash chip on here. And all we have to do is sit there and listen, and we can see unencrypted firmware. Or we can actually go and dump the firmware off. So maybe people should be encrypting their firmware. But the other thing we've got is JTAG and hardware interfaces, hardware debug interfaces. As long as we've got those enabled, like we still have this like baseline low level, people are leaving their doors open. But people are starting to fix these things. We're starting to get hardware that's a little more secure. So what we have to do as hardware attackers is look at the next level of interfaces. So PCI Express is something I've been poking at for a long time. The problem with PCI Express is all the equipment is expensive and hard. And instead of just spitting out a bunch of characters over a wire like Serial does, we spit out a bunch of data that gets scrambled and swizzled and gets bits stuffed in between, and it's speeding across at 2.5 to 8 gigahertz, right? So it's kind of complicated. I'm 5 seconds behind. So the thing is, PCI Express is also designed to be idiot-friendly, right? It's designed to use these high-speed interfaces and just kind of work. So a lot of it is designed to automatically reconnect if it gets disconnected, kind of like a network interface might be. So let's look at a couple places where you can find PCI Express interfaces. So we've got the Slotscreamer, which is this hardware device I used several years ago. It costs about $100, and you have to plug it in a slot in a system, and then you can go and do DMA attacks. You can read and write the contents of memory, right? MacBooks and a few other systems now do a good job of protecting hardware against these writes from these malicious devices plugged in them or plugged in Thunderbolt slots. So then we've got the next level, which was PCI leech, right? This took over because now we've got an FPGA that we can configure to our whatever we want versus this old ancient 32-bit chip. These cards cost quite a bit more. They're quite a bit bigger. You can't go and sneak in and pop this in someone's laptop, right? So we've got a new round of devices. PCI Screamer is kind of a custom board designed specifically for hardware PCI Express stuff. There's a smaller version you can see on the right, the M.2 format, which is the size of a hard drive, which I don't have lying around right now. But one I've been really excited about is this one called PicoEVB. PicoDMA is the toolchain that works with it. Basically, we have this tiny little board that pops into the slot in a system where you would normally plug a network adapter, and it can go and do DMA attacks. So we've talked about like laptops and desktops and servers and all these operating systems that do a good job of protecting its malicious hardware. But what about the devices that are kind of lower end, or devices we don't really think about? So first, we want to find a PCI Express slot. This is the bottom of a laptop I recently grabbed. On the left side, we have 2 NVMe drives, right? They're pretty tiny. That's the kind of slot that one of these little devices would fit into. On the right side, you can barely make it out. There's a white patch with a QR code. That's the, what's it called? The network adapter. Again, we put this laptop to sleep while it's still running, pop out the NVMe and the network adapter, plug this little malicious board in and power the system back up, and PCI Express is just happy to resume and let us access all of memory. Here we've got embedded devices. This is a Wi-Fi router that happens to have an extra slot on it with a PCI Express interface so that we can go and plug in a 4G module, right? The 4G module basically would let us go and connect to 4G or 5G or anything else, but we can also take that module out, pop in our attack device, and move along. I've got this device here. It's a Pogo plug. It's a cheap home network device. And it turns out this $5 chip that it uses actually supports PCI Express. Just doesn't have a slot built into it. What do? Open it up, solder the right wires in the right spots, and then plug in your device. So we can take an embedded device that has PCI Express and suddenly get physical access this way. Who's been wasting all their time on one of these? A Nintendo Switch, right? This is the inside of a Nintendo Switch. On the right-hand side, we see a little metal case, and just below it, there are a couple gold pads and a couple of gray components. Those are capacitors. Those are capacitors on the PCI Express lines between the switch's CPU and the network adapter. If we desolder those capacitors, we can man in the middle the PCI Express link to the network adapter. And again, the network adapter has to read and write memory to get its job done. So it's there. Raspberry Pi, these tiny little cheap $35 computers happen to have on the latest version a PCI Express USB hub, right? So this means it connects to PCI Express to the chip. If we look for the data sheet for that chip, we can find out where those pins are. And there's a great blog post about taking this chip off and basically giving us an external PCI Express port on a Raspberry Pi. I'm totally losing time, but I have no idea how much I've gone through. But where else do we find PCI Express, right? Nikon Z7 has a memory card that happens to use PCI Express, right? So we've thought about it in these high-end devices, but when we're talking about something that's running bare metal code on a proprietary instruction set architecture that happens to have PCI Express that uses it to read and write the contents of memory, we might have an opportunity there. Also, the new Xbox, the new one that's coming out soon, is also going to have PCI Express-based memory cards. So hopefully they've done their due diligence of blocking that interface on those things. How many of you ever dealt with a server of some sort, like with a storage server? Well, so now that we have hard drives that are using NVMe, which is PCI Express, we want to basically hot swap the drives right out the front of the case. So what we've got is we've got racks and racks and racks of servers with slots, with drives that we can pull out that are PCI Express capable. And that basically means we have hot swappable, DMA accessible interfaces exposed in the front of every single server. We don't have to open the case. And of course, we've got our servers with BMCs. These BMCs are connected via PCI Express to the host. So if you have software execution on the BMC, there is a feasible path to go and do memory access to the host. It uses this PCI Express interface to pretend to be a graphics card to the host. And finally, even if we don't have extra devices on there, if we have a server with switches that branch out all our multiple PCI Express interfaces, then we might have this chip right here that we can go and hook up debug port to and go and basically create some Puppet spoofed PCI Express transactions to go and read and write the contents of memory. So I completely lost track of time. I think I've done 20 seconds per slide. Perhaps I haven't. You can criticize me on Twitter. But basically, exploiting UART and unsigned firmware and unblocked debugging ports is trivial. It's easy. It's like baby stuff, right? High-speed interfaces are fast, they're cheap, and now they're pervasive. And even though we might think, oh yeah, for now we'll use the UART path, but very soon when these easy approaches are are fixed up, we're going to have to go to the high-speed interfaces. But it's just a speed bump. Expect the availability of inexpensive tools to make it trivial very soon. Thank you.
Thank you very much, Joseph. That was incredible. You were perfect. Everything was exactly at 20 seconds. You moved the slides at exactly the right time. No complaints whatsoever. You were perfect. So thank you very much. Not a lot of questions from the audience because I imagine they were trying to keep up with your with the flow. My question to you is just very quickly following up from your talk in Singapore and this talk. Are we likely to see a grain of rice embedded in a server somewhere?
A grain of rice itself probably won't help much, but a device the size of a grain of rice would be pretty bad. I don't know if you can see on my microscope right behind me where we've got a grain of rice up there. Yeah, I think that it's feasible that stuff like this happens. I think that it's feasible that people don't look inside their hardware, so they aren't going to be able to detect this. However, we're in a world where there are so many easier ways to cause all these problems that we need to understand, we have to have threat model, who's going to take the time, have the risk, have the effort to go and implant hardware when there's so many easier paths to get there.
Quick question from the chat room. Will connecting to the PCIe bus disrupt the communication?
If there is already a device in there and you pull the device out, yes, it will. If there's already a device in there, you can't just stick probes on there and listen. It's too fast. The equipment to do that is not feasible. However, if you put a system to sleep, take out a card, put your malicious card in and wake it back up, most of the time it automatically reconnects and won't even check to make sure that you're still the network adapter and just let you do all the memory access you want.
Thank you, Joseph. Is that a garage or an office?
Yeah.
Good answer.
It's a shed.
So what's your,
it's a shed that is my office, world headquarters. So.
Two last questions. Can you confirm that 5G doesn't cause COVID-19?
I know places that don't have 5G that do have COVID-19, so I don't see a causal relationship.
What is the best part of quarantine and the worst part of quarantine for you?
The best part of quarantine is having not been on an airplane at this point for 5 months. The worst part of quarantine is that, the thing I miss about going to events like SAS and elsewhere is the face-to-face one-on-one conversations that, we can have these webcasts, we can have the chats, but, getting that opportunity to have one-on-one conversations with so many different people with different perspectives is really what I'm really missing.
On a more serious note, Joe, your business is the traveling to the event business and putting together training. What happens to your business here, and where can the folks find you to purchase the training? Are you going to do something virtual? This is the place you get to advertise it to the SaaS audience.
Well, I have basically been lucky that all of my clients so far are postponing instead of canceling. However, what I've realized I need to do is I have a series of 6 classes that go from beginner to pretty advanced. And the first class is going to have to go virtual. And so that's what I've been working on the past few weeks is taking that class. Basically, what I'll do is I'll ship people a hardware kit, which they get to keep, some software requirements. And then we have, the lectures and the Q&A can be like this, but they get their hands on time with hardware, which they get to break and keep. So hopefully that'll work out well. And that's going to be the new normal. And so hopefully the advanced classes, I don't know how I'm going to be able to, send you a PCB milling machine for a short class, but we'll keep the advanced classes as on-site and smaller groups as they have been, but the intro class is going to have to end up being virtual. So,
where can the folks find all the information?
securinghardware.com. That's me, my website. I should probably have like a